Morning children. Children, as you know that we are continuing with the lesson sound, and in my last video I taught you some basic types of waves that can be categorized as mechanical waves. As you know that mechanical wave, sound is a form of mechanical wave, it's an example of a mechanical wave, and it requires a medium for its propagation. So in my last class we learned about longitudinal waves and transverse waves, which are nothing but mechanical waves. And sound is a form of longitudinal waves. Actually it propagates in the form of compression. What are the two things, regions in that wave called? Those are compressions and rarefactions. Yes children? So do you remember the particles of the medium, they vibrate to and fro, and that vibration will be in a direction parallel to the propagation of wave. The wave, if it moves from this side to this side, the vibrations also will be in the direction parallel to it. It won't be perpendicular to it. If they are parallel, they are categorized as longitudinal waves. So we have seen that sound is an example for longitudinal waves. Today we will be learning some terms related to waves, children. So this one, it's actually more or less, almost, it's like the same. It can be related to the pendulum, simple pendulum. Do you recall, children, what we learned in our seventh class? Actually, the simple pendulum, we did some experiments to find out the time period of a simple pendulum which oscillates to and fro. Yes children, so it oscillates to and fro in a particular time. We have learned some terms there like amplitude, time period, frequency, isn't it children? So in the similar manner, for a sound wave, for a wave also we have all those terms. So because you have already learnt about the simple pendulum, I think it should not be much difficult for you to understand these terms now. So we can relate this sound, a wave like this. Actually graphically it is represented in this manner, children. As I told you, transverse waves have a crest that is nothing but the upper. These are nothing but graphically it is representing the to and fro motions of the particles of the medium. So at this point the displacement is maximum, children. I'll relate it to the simple pendulum. Actually it is nothing but a heavy bob which is suspended, isn't it? And if it is just allowed to oscillate, what happens? First, from this it goes to another position, right children? So you can see that this is the mean position. This is the mean position, and when I just pull this to one side and leave, what happens? Because of the gravity and inertia, you will learn that in later in higher classes. Because of the gravity it will be pulled down, it can't remain in this position, right? So it tries to come down, but will it stop here? No, it goes to the other end as well here, and then again it tries to come. So this is again repeated so that you get to and fro motions, which is nothing but called as oscillations, right children? So in the similar manner, this is the mean position here. Graphically it is represented like this. First it goes to one extreme, one end here, and then it comes back to the mean position and again goes to the other side and reaches the maximum displacement and comes back to the mean position. So do you remember, one oscillation is equal to, how much is one oscillation? Like if the bob from this end to this end, if it goes, is it called one oscillation? No, it has to come back to its starting point. Do you remember children that we did one experiment where we calculated time period of a simple pendulum? How did we count? First we released the bob here, it went to the other side and it came back again. Then we counted that as one oscillation. You remember? So in the similar manner, one wave, how much is one wave? How do you calculate what is one wave? It is nothing but first it starts from the mean position, it goes up, it comes back to the mean position, goes to the other end, and it should come back to the mean position. This is the starting point and it comes back to the starting line, that means mean position. Then it is called as one wave. You can see here that one wave consists of one crest and one trough. So the upper position, this part is known as the crest, children, okay? And then the down part is known as the trough. This is crest and this is trough. together it is called as one wave or one oscillation. You remember from point, for example, this is point A, this is point B and this is point C. In order to complete one oscillation, the bob has first, it should go to B, it will go to B, B to C, then C to B again and B to A again. Right children? Do you remember? In the similar manner, this A to this end, then comes to B and again it goes to this end and comes to C. That is one oscillation or one wave. Okay children? What is one oscillation? It is nothing but one complete to and fro movement of the wave. Did you get that? So here you can see that one oscillation consists of one complete to and fro wave. We have one crest and one trough. If it completes one crest and one trough, then it is called as one oscillation. Let me see if you understood this or not. So there is another graphical representation of a wave like this. Can you tell me how many waves I drew here? Can you tell me? So on the x-axis we take time children, okay? On the x-axis we take time and this is displacement actually. This side, y on the y-axis we take displacement. You will learn this in higher classes. For now you understand that a wave is graphically represented like this. So you can see now how many waves did I draw here? One wave, how many crests and how many troughs it should have? One crest and one trough. So you can see this is one. From here, this is one crest. And from here, this is trough. So it completes one wave. Now like that from here, a next wave starts. One crest and one trough. So how many together? I have drawn here two waves. Got it children? So two oscillations. So it made two oscillations. Now coming to the wavelength. This is another thing that you need to know. A wavelength is nothing but a distance between two consecutive crests or two consecutive troughs. So it's not that from here to here, it is not wavelength. What is one wavelength? We'll see what is one wavelength actually. The distance between two crests. Crest is nothing but the highest point. Trough is nothing but the lowest point. The distance between two crests or two troughs is nothing but a wavelength. Got it children? Actually if you see this distance and this distance, like from here to here or from here to here, both will be same actually, but for the convenience we just saw here, no, like we can't know what is the mean position in a simple pendulum. You remember we counted from one extreme to the other only, but we can't know what is the mean position, right? So from one extreme to the back to the other extreme. So if we start from A, we have to count the next, when the bob comes back to A, then we count that as one oscillation, no? In the similar manner, the distance will be calculated between the crests or the troughs here children. Two crests, topmost points in a wave. Between this, what is the length between these two things is considered as one wavelength. And you know the symbol of wavelength? It is called as lambda. What is the symbol of wavelength? Wavelength is represented by a symbol lambda. Amplitude. You know this amplitude, right children? What is an amplitude? It is the maximum displacement of the wave in any direction. You can see that here the displacement at this point of the graph, the displacement is less only. Here also the displacement is less from the mean position. This is the mean position. If you talk about simple pendulum, B is the mean position here, right children? So how much distance it is covering both the sides? That is nothing but the amplitude. Maximum displacement from the mean position is called as amplitude, correct? So that means for this wave, for this oscillation from B to A, the distance between B to A or B to C is nothing but amplitude. So in this case, what could be the amplitude children? The topmost point or the downmost, bottommost point. That is called as the amplitude. What is the definition of amplitude? It is the maximum displacement of the wave. Okay. So this is the maximum displacement. Now I'll draw figures actually, and you have to tell me in which of the figure the amplitude is more. See, in one we have, okay, in another we have, can you tell me in which wave do you think is the amplitude more? You can see the distance between the mean position and the top, what you call maximum displacement, the topmost. Can you see the distance is more here? The vibrations or the to and from motions are more here. So the deviation is more from the mean position. Here, can you see comparatively this distance is lesser. So this is a wave with greater amplitude and this is a wave with lesser amplitude. Okay. What is amplitude? It is the maximum displacement. Actually the particle was here. This is the mean position. Once the energy is transmitted, sound energy or whatever sound energy, then what happens? There will be disturbance in the medium. The particle which was actually here, it will start moving to and fro. That means it may either move up or move down. So that displacement, if we measure, then it is called as amplitude, children. Now time period. You remember the time period, how we calculated for simple pendulum. What is the time period? It is the time taken for one oscillation. It is the time taken for one oscillation. One oscillation we know. For a wave, one oscillation means it is one crest and one trough. Right, children? So how much time is it taking to complete one oscillation? It's nothing but time period. And the SI unit is seconds, children. Second is the SI unit. So when you are drawing the graph on x-axis, we take the time period. So 1 second. In 1 second, how many waves are produced? Okay. So the what is it actually? What is the time required for making one oscillation? It is nothing but called as time period. Now there is a close relationship between time period and frequency, children. Now what is frequency now? Frequency is nothing but number of waves that are happening or that are made in 1 second. Number of oscillations made in 1 second is called as frequency. That means if more number of waves are made in 1 second, they are happening in 1 second, then we call it as high frequency. Very few are happening in 1 second, then it is called as low frequency. Correct, children? So there is like, I'll show you another example. This is the timeline. Time is taken on x-axis and this is 1. From here to here, it is 1 second, for example. Okay? Now this is one case. How many waves are happening in 1 second here? One wave only. But in another case, this is again 1 second time. This is 1 second time only. Remember, what is the frequency here? In 1 second, how many waves are made? So now, can you see how many waves did I draw there? Can you count? One crest, one trough. One wave, one crest, one trough. Two waves, one crest, one trough. Three waves. How many waves have crossed in 1 second here? 3 waves. What is the frequency here? One wave in 1 second. And here, what is the frequency? 3 waves in 1 second, children. Okay? What is frequency now? It is measured in hertz, children. Hertz. Hertz is the SI unit of frequency. Hertz is the SI unit of frequency. What is frequency? How many waves are produced in 1 second? How many waves are produced or crossed in 1 second? What is time period? What is time period? It is the time taken for one wave. It is the time taken for one wave. But whereas frequency is how many waves are produced in 1 second. Okay, children? So time period and frequency, they are related. They are actually related. They are inversely proportional actually. So F is equal to 1 by T. We can say that F is equal to 1 by T. That means they are related in this manner. Time period and frequency are inversely related. Proportionality symbol we say F is equal to F. Small f is equal to 1 by T. That means if time period increases, frequency decreases. If time period decreases, frequency increases. So these are the terms that you should be knowing before we go further in the chapter, children? Already we know all these three. Only this also we know. Only wavelength is a new concept for you in with respect to crests and troughs. Okay. So this is for today's class. In tomorrow's class, we will learn how the amplitude, time period and frequency, when they change, what effect it has on the sound quality, children. In next class, we'll learn about these things and what are the various, how does the sound gets affected by different factors.